Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized pieces.
Today, we're talking about a problem that feels like it's straight out of science fiction, but is becoming more and more real: audio deepfakes.
You've probably heard about these. Maybe you saw the story about the fake robocall from President Joe Biden telling people not to vote, or heard about scammers using an AI-generated voice of Elon Musk to promote cryptocurrency schemes.
Exactly. It's getting scarily easy to create a convincing audio clip of a public figure saying something they never actually said. So the big question is, in a world full of AI-generated voices, how can we tell what's real and what's fake?
You'd think our best bet would be to build super advanced AI detectors to fight fire with fire, and we have. But according to a new paper from researchers at Northwestern and Bar Ilan universities, most of these detectors have a huge blind spot.
Right. Most current deepfake detectors work by analyzing only the audio file itself. They listen for tiny, microscopic flaws in the sound waves, artifacts that a human ear would never notice, to decide if it's real or AI-generated.
It's like trying to spot a counterfeit dollar bill by only looking at the ink molecules without ever looking at the picture on the bill. It's missing the most obvious clues.
And that's the core idea of this paper. Humans don't just listen to the sound. We use context. If you heard a crystal clear recording of Queen Elizabeth I reviewing the latest smartphone, you'd know it was fake instantly. Not because the audio sounded weird, but because the context is completely wrong.
The researchers wanted to give that same kind of common sense to an AI. They argue that when we're dealing with deepfakes of public figures, there's a treasure trove of contextual information that current detectors just ignore.
So they built a new system called CAD, which stands for Context-Based Audio Deepfake Detector. It doesn't just listen to the audio file, it also looks at two other crucial pieces of information: the transcript and the context.
The transcript is simply the written text of what's being said in the audio, and the context is where it gets really clever. CAD automatically scours the internet for information about the person who is supposedly speaking. It pulls recent news articles, their social media posts, and even their biographical data from sites like Wikidata.
So CAD analyzes three things at once: the audio itself, the words being said, and the real-world situation surrounding the person saying them. The idea is that a deepfake might get the voice right, but it's much harder for it to match the context perfectly.
But to prove this works, you need some really good fakes to test it on, and that was another problem the researchers found. A lot of the existing datasets used for training AI detectors are, well, a bit silly.
Yeah, the paper mentions one popular dataset that includes a clip of Donald Trump reads Star Wars. It's so obviously out of character that it's incredibly easy to flag as fake. Using that to test your detector is like giving it a first-grade spelling test and then claiming it's a genius.
So the research team created their own much tougher dataset. They called it the Journalist Provided Deepfake Dataset, or JDD. They worked with over 70 journalists from around the world who submitted real-life deepfakes that they had encountered in their work, clips that were genuinely tricky to verify.
This wasn't a spelling test. This was the final exam. These were the deepfakes designed to deceive, the ones that current systems struggle with. So they put the old detectors and their new CAD system to the test on this dataset, and the results were pretty dramatic.
They were. The old models that only looked at the audio file performed very poorly on the journalist dataset, but when they were enhanced with the CAD system, giving them access to transcripts and context, their performance shot up.
And not by a little. The paper reports that accuracy in spotting fakes improved by anywhere from 5% to over 37%. On the hardest, most realistic fakes, adding context was the difference between basically guessing and getting it right almost every time.
What I thought was even cooler was the robustness test. The researchers know that people who make deepfakes will try to fool detectors. They might add background noise, compress the audio file to make it sound scratchy, or even stretch or slow down the audio.
They call these adversarial manipulations, and when they tried these tricks, the performance of the old detectors dropped significantly, but CAD, with its use of context, was barely affected. Its performance only degraded by less than 1% on average.
It makes perfect sense. You can put a disguise on the audio, but you can't disguise the context. If the audio is of a politician who passed away last year suddenly endorsing a candidate for next week's election, no amount of background noise is going to make that seem real. The context gives it away.
The paper also had a fascinating little side note. They found it's significantly harder for AI to detect deepfakes of politicians compared to entertainment figures.
Why is that?
The theory is that political speech is just more complex. It has more diverse topics and more complicated language. Entertainment deepfakes, which are often used for scams, tend to follow more predictable patterns, making them easier for an AI to recognize.
So, what's the big takeaway here?
The conclusion is pretty clear. To build better deepfake detectors, we need to build them to think more like humans. We need them to look beyond the pixels and sound waves and consider the bigger picture. Context is king.
And this approach isn't just for audio. The researchers suggest that using context and transcripts could also make a huge difference in detecting deepfake videos by analyzing the audio track for inconsistencies.
It's a powerful reminder that sometimes the most advanced solution isn't about more complex algorithms, but about giving those algorithms the right kind of information to work with, the kind of information we use every day without even thinking about it.
And that's all for today's Daily Papers. Join us next time for another look at the research that's shaping our world.